Welcome to the European Non-Associative Algebra Center. It's a pleasure to introduce today talk by Ilya Gorshkov from Sobolev Institute of Mathematics, Novosibirsk, Russia. And he's going to talk on pseudo-composition algebras as axial algebras. Please.
Oh, okay. First of all, I'm very thankful for opportunity to make this talk. I will speak about pseudo-composition algebras and the axial way of these algebras. And okay, let's start. Okay. First of all, I need any definition about axial algebras. And this is the next definition. Let F is a field F, and F calligraphic is any subset of our field. Usually this field, this subset is finite, not finite, it's very small finite subset. And we define a fusion table or fusion law on this subset. It's some operation from F across F to subset of F, and usually we will use for fusion table the same symbol F calligraphic. Any examples of fusion law? First fusion law is a fusion law of pseudo-composition type eta. Here our subset of field include three elements, one eta and 1/2, and on intersection 1/2 and 1/2 we see eta, 1. It signifies that half cross half is equal set which include two elements eta and 1. Next, second fusion table is a Jordan type fusion table. We see that here too we have only three elements, 1, 0, and eta, and on intersection 1 and 0 we see that empty set. It signifies that 1 cross 0 is equal empty set. And third fusion table is a fusion table of Jordan type alpha beta. This is generalization of first and second fusion law. For example, if alpha is equal 0 and beta is equal eta, we get that fusion table Jordan type alpha beta is equal of Jordan type eta fusion law. And for another parameters alpha and beta, we can get a fusion table of pseudo-composition type eta. Any more definitions? Let we have any commutative but not necessarily associative algebra A, and we can define an adjoint operator. It's multiplication on element A. And because algebra is commutative, it doesn't matter left multiplication or right multiplication. And for this adjoint operator for any elements A, we can define an eigenvalues and eigenspaces. If you take any lambda of our field F, then A sub lambda A, define eigenspace with eigenvalue lambda. And if you take any subset, lambda capital of our field, then A sub lambda capital A is a direct product of our eigen spaces with eigenvalues lambda, where lambda is an element of lambda capital. Okay, now we can define what does it exist. We have any fusion rule F calligraphic, and if we take an idempotent A of algebra A, then this idempotent is f-axis, or if we know F, sometimes we will lost F and said that A is axis if entire algebra A is a product of eigenspaces with eigenvalues from F calligraphic, and multiplication on these eigenspaces satisfy a multiplication in a fusion law. And of course, since our algebra A is a commutative, our fusion rule must be asymmetric, and because A is idempotent, F include a 1. And we said that our axis is primitive if eigenspace with eigenvalue 1 has dimension 1. And in 2015, John Hall, Felix Lerin, and Sergei Spektorov define an axial algebra. Algebra A, commutative algebra A, is a f-axial algebra if it's generated by f-axis, and primitive axial f-algebra if A generated by primitive f-axis. Okay, more example. If we take this fusion law, which includes 4 numbers, 0, 1, 1/4, and 1/32, and this fusion law I think is a first fusion law which we can find in any articles, because if you take Grice algebra, this is a finite dimensional non-associative commutative algebra, but this is very big algebra generated by 3 primitive axes with this fusion law. This fusion law has name a monster type fusion law, because group of automorphisms of Grice algebra is a monster group, biggest sporadic group. This group include almost all another sporadic group, and this is a really very big group. And I think this algebra, Grice algebra, generate all this theory of axial algebras. First generalization of Grice algebra was a Majorana theory, and later Hall, Lerin, and Peirce generalize a Majorana theory and get an axial algebras. Okay, now I want to define Jordan type algebras. If we take a Jordan law type eta, then algebra of Jordan type eta is an commutative algebra generated by primitive axis of Jordan type eta axis. And this fusion law has a name at Jordan. That is because Jordan algebras has a Peirce decomposition. It's mean the next. If you take any idempotent in a Jordan algebra, Peirce decomposition signifies that all Jordan algebra is a product of eigenspaces of adjoint operator of this idempotent with any eigenvalue 1, 0, and 1/2 with fusion law of Jordan type 1/2. From Peirce decomposition, we have that all algebras of Jordan type. From Peirce decomposition, we have the Jordan algebra is generated by primitive idempotents is Jordan type half algebra. But if we take a Jordan type half algebra, it doesn't signify that this algebra is a Jordan. For example, we can construct many algebras which is Jordan type half, but not a Jordan algebras. Okay. Next, for a useful definition, if we have an bilinear form on commutative algebra A, then this bilinear form is a Frobenius form if it's associative with a product on this algebra. And Paul Segev and Spektrov in 2018 show that these Jordan algebras include a unique Frobenius form with a property that A is equal 1 for each axis, for each primitive axis A. Okay. This what about an axial view? And now I need to define pseudo-composition algebras and train algebras. Okay, let we have a field of characteristic node 2 and node 3, and we have a commutative F algebra A with a symmetric bilinear form phi. This algebra is a pseudo-composition algebra is if x cube is equal fxx multiplied by x. These algebras was introduced like some generalization of composition algebras, and there is a lot result about these algebras, but it's interesting for us only results which we can use when we look on this algebra like an axial algebra. And one of these results is a result of El-Duque and Akuba, they prove that the symmetric linear form, which we use for definition of pseudo-composition algebra, is a Frobenius form. Okay, now I need to define a train algebra. Let A be a commutative algebra over a field F, characteristic node 2 and node 3. Then we can define a principal power. In general, we cannot say that there is a power of any elements because, for example, a square multiplied by a square doesn't equal x cube multiplied by x. But we said that there is a principal power of algebra A. It's defined by the next way. X power 1 is equal x, and x power e is equal x power e minus y minus 1 multiplied by x. Next definition, we said that algebra is baric if there exists a homomorphism from A to F, non-trivial homomorphism. In this case, we said that our homomorphism omega is weight function, and algebra is a baric algebra. And we said that algebra A is a train algebra if it is a baric algebra and pair with a pair A omega, and this is train algebra of rank R. If there exist elements of our field lambda 1, lambda r minus 1, such that for each x of A, we have this equation. These algebras was introduced almost 100 year past, like some formalization of genetics way. Okay, and we want to say in finally that these algebras, train algebras, pseudo-composition algebras, is good axial algebras, and using axial way to make function in these algebras. For this, we need some theorems, and one of these theorems is the next. Walcher in 1999 proved that if you take a pseudo-composition algebra and eta equal -1, or a train algebra of rank 3 and eta doesn't equal -1, if we take an idempotent E of this algebra, then we can define then we know that our algebra A is a product of eigenspaces with eigenvalue 1, eta, and half, and dimension of one eigenspace for idempotent E is 1, and multiplication on these eigenspaces satisfy pseudo-composition eta type fusion law. In particular, this signifies that if A generated by idempotent, then A is a axial algebra of pseudo-composition eta type. In general, this theorem is Peirce decomposition theorem about Peirce decomposition for these algebras, and we see that these algebras of this type has a good Peirce decomposition and has a good fusion law. And in general, we want to inverse this theorem. For example, for Jordan algebras, we cannot inverse this theorem. There is a lot algebras which include Peirce decomposition or generated by idempotents with needed fusion law, but these algebras isn't Jordan. For example, a big series of Matsuo algebras and question about does there exist no Jordan and no Matsuo algebras of Jordan type? Half is open. It's a very difficult question. But for train algebras and pseudo-composition algebras, we can invert this theorem. And this is our goal. Okay, and I want to formulate any theorem which we need to prove for proof our final goal. And first of this theorem is the next. We need to classify two generated pseudo-composition axial algebra of pseudo-composition eta type. Okay, if we take algebra A and generated by two primitive axes of pseudo-composition eta type, then algebra generated by these two axes has dimension and at last 3, and here on my first block I describe a multiplication of these two axes. Like a corollary of this theorem, we get that algebra generated by A and B, axis of pseudo-composition eta type, is spanned by elements A, B, and AB. Another theorem, these algebras can be two-dimensional, and we too need to classify this algebra. Let me take A, B, and oh, okay. On this theorem, I have any description how we can multiply these two axes if algebra generated by A and B is two-dimensional. And like a corollary of these two theorem, like a corollary of these two theorem, I get the next theorem. If we take algebra A, pseudo-composition eta type, then A is a linear span on set of primitive axes. In particular, this algebra includes bases which consist of primitive axes. Plus minus the same situation in an algebras of Jordan type half. In Jordan type algebras, everywhere there is basis which consist on primitive axes. And the next theorem that pseudo-composition eta type algebras include a unique Frobenius form such that AA is equal 1 for all primitive axes 1. This theorem is the same like theorem of Segev, Ryan, and Spektrov. Okay. What we can say about train algebras? Suppose that eta doesn't equal -1, and A is a pseudo-composition eta type axial algebra. We have any Frobenius form on this algebra, and this Frobenius form has the next property. If A and B are primitive axes of A, then AB is equal 1. And we can define a weight function which depend on axis A. And this weight function is a function from A to our field F. Yeah, I'm sorry, I forget to say that everywhere we mean that F is characteristic not 2 and not 3. This is useful for correct definition fusion law. And okay, this theorem signifies that if eta doesn't equal -1, then every self-decomposition eta axial algebra is a Baryk algebra, and with any axis A, we can bound any weight function. Okay, like a corollary of previous theorem, we can accumulate all what we know about train algebras and pseudo-composition algebras and inverse a Peirce decomposition. We can say that if algebra generated by a primitive axis of pseudo-composition type eta, then if eta is equal -1, then A is a pseudo-composition algebra. And if eta doesn't equal -1, then A is a train algebra of rank 3. And we build a full description of 3 generated pseudo-composition eta algebras. In particular, we prove that 3 generated by 3 primitive axes pseudo-composition eta algebra has dimension at last than 8, and in our article you can see a multiplication table. In particular, we have the next eigenspaces for any axis A. Okay, I think I finished. But before I want to make any advertisement. Tomorrow we start a seminar on axial algebra. If you want to connect to this seminar, you can write me an email and I give you link for online of this seminar. Okay, thank you.
Thank you very much for your talk and for the announcement that you have made about your seminar. Are there questions?
I have comments and questions, okay? So because, yeah,
Yes.
Thank you for a nice talk, so nice results. Maybe it would be interesting also to hear how it works. But I have two comments. I looked at your paper, okay, and you do not cite my two papers, which you actually cite Vibro paper 2020 about some special property 1/2, and I published in Archive 2018 and in Journal of Algebra in 2020. Okay, when you try, excuse me, okay, when you try in the paper on the first page, you try to motivate why you're looking for, and also composition algebras, and another variant of them and another setting. I think it's also maybe important if you look after a talk at my paper 2015, also in Journal of Algebra. So this is Jordan.
Mhm.
I can show you reference, and certainly I don't know why you don't mention that. Okay, so for me it's a little bit strange because exactly this table appears in other algebras in Xiang. I already gave several talks, so maybe you have to be attentive and come back and try to refer them. Okay, so because this situation is not new. I don't refer to your results, of course, okay? So, but some of them you can consult me and we can discuss. Okay, so I think you have to.
Thank you very much, Volodya. Yes, I remember we talked about it with you and about sound algebras. I have any idea how to use these algebras, but what's about sound algebras? A fusion law of these algebras include very many subsets.
I mean, so if you look at some papers, a subclass of Hahn algebras have exactly the composition algebra structure, quasi-composition algebra structure.
Yeah, I understand.
And exactly the same table for minus one, okay.
Yeah.
So I just wonder why you don't refer to them. Okay.
Yes, I see your
And
paper.
one can
I
also
understand.
do it by Freudian construction and so on. Okay, so just my remarks. I think it should be mentioned because it's in the context.
Yeah.
Okay.
Maybe, but I try to use it, but I
we can
don't
discuss it.
think
Okay.
how. Yeah. Okay. Thank you.
Thank you for the question. I can see there are some requests in the chat. One of them from Luis Robin about the contact info for the seminar in axial algebras. So I think you said that the way to connect your seminar is to write an email to you and then you send the link. Is that correct?
Yeah, I will make a post on group pub forum, and I have yes. If you write me on email, I get you a link. If I can it another way, same here, I can publish anywhere link of our seminar, and if
Well, we can give you the list of the participants of this seminar, and then you will send your link to everyone. And there is one more question. Could you give the reference for the result of, I don't know how to read the surname. Is it German or English? Barcher or Welcher? Do you know about this paper? Have some problem with connection. So, Florin, you are asking for the reference which was given on the slide.
Yeah.
So I think our speaker is.
I'm here. I search link. Yeah, I'm here. Yeah. 1 second. Oh yeah. Yeah. I'm sorry. I'm sorry. I'm sorry. Another one. Yeah. This one. Yeah.
Thank you.
And
here
on chat, I can give you a link on our Excel seminar. Okay. This is link for connection, and this is link for site of our seminar.
Okay,
yeah,
perfect.
And here we have a record of our talks.
And do you have here a schedule of your? Yeah, I see. 35 will be on tomorrow. Okay. Thank you. Any more questions, comments? Okay, so we thank Ilya for his talk once again.
Okay. Thank you.
Thank you very much. And I guess we can end our session today. I wish you all a good week and see you later.
Okay. Thank you very much.
Bye.
Goodbye.
Bye.